Wednesday. Please bring your laptop, then we have very short exercise lab regarding to the GCP. Then later, in the middle of the semester, we are going to have the BigQuery, using the BigQuery exercise lab based on the GCP. Meanwhile, you can use feel free to use the Google free $50 the coupon. If you already took my course before, last semester you probably used the same thing, so it's good for you for your practice. And some of you guys probably can use the GCP account for your big data project also. Okay, so let's discuss about the characteristic of the big data. Somebody define actually starting from the 3V. Nowadays it's a 4, 6, 8V. But I think like the first 3V and plus 1, 1. So first the volume. Needless to say, so big data is a bit. Okay, so volume is the important characteristic of the big data. So it's not the. However, when we talk about the size of the big data, considering the computing power, is the personal computing power is up to the terabyte, several terabyte is the big data. So we need to consider some of the big data solution focusing on the personal computing power, like the Microsoft Azure. So there is something the individual the Hadoop system. Then the company size is several petabytes to the exabyte. The size of the data. So anyway, the volume is the most important characteristic of the big data. Their growing rate is almost exponential, like this one. So that is a problem. So that is a reason why we need to consider the big data solution. Second characteristic of the big data is the variety, which means traditionally we use the very well organized data. It's a structured data. If you think about the relational database model, probably I mentioned many times, the relational database model is a very strict model. So because of that, you can get the benefit of the big data, benefit of the structured model when we access the data. Because it's well organized, it's probably fast to search the data, to retrieve the data. If it's not organized very well, if you think about your dormitory or your room, if your room is not organized, it's very hard to find something, the book or your clothes or anything. But if your room is well organized, then it's very easy to find. So that is the reason the relational database model traditionally is a very strict model. However, nowadays, since we have so we collect the input data is huge, so there's no time to well organize. So also we don't want to throw away we don't know whether this is important, this is not important. So we just keep all the data as it is. So that is the variety of the data. So like not only text and numerical data, nowadays the image, audio, even though the relational database management system, the claim they can support the image and audio video data, actually nobody uses that because due to the natural characteristic of the relational model, it cannot support the image and the video data. So only the alphanumeric data. But the big data solution is the image, audio, and the video. Especially the time series data is also important. There are two important characteristics of the big data. One is the spatial data, which means the GPS location, GPS information. So, and another characteristic is the time, along the time, like if you think about the stock market, the price. So it's along the time. Then if we can decide whether this is going up or going down or gain or lose, that's it, the game is done. So we don't have to study this one, just to use the going up or the going down, then we can invest. So nowadays, such a time series, the sequence data along the time and the spatial information are very important characteristics of the data. Another important part is the social media data. Social media data nowadays, everywhere, Which one is the most popular, the social media data? Facebook, Twitter, Tumblr, and Snapchat? Snapchat had a problem recently. But anyway, so those are the things I know. But there are many others. So any kind of the social media data, the basic idea is connect. How much connect? The more a friend you have, the better. It's the most important part for that company. So Facebook really wants more and more friends, more and more likes, and the Twitter has more and more the follower. The more connected, then they can do their business. So then, to keep such a connection, the traditional data type, this data structure is not easy. So instead, we can use the graph data structure and other thing. Okay, and multi-dimensional data, so it's a variety of the data structure. Also, the traditional data type is a static data, which means it's, for example, think about the data warehousing system, which was popular in the 1990 and the early 2000s. Still, some of the companies are using the data warehousing system. What their data warehousing system is doing is they collect all the data daily. Then, at night, they send the data to the data warehousing system, like the big storage, then process at night. Okay? It's the day by day, or sometimes it's a week by week, the processing. It's the static data. However, nowadays, the even banking system and many of the company, their business is 24 hours, 7 days, which means it's keep coming. The incoming data is a streaming data. So another characteristic of the big data is nowadays the streaming data. So it's more and more complex. The data types of variety. So volume and the variety is the characteristic of the data. Then the third characteristic is the velocity. Velocity means the generating speed of the data is fast and fast. Okay, so it's keep coming, and even that is the faster, and even the second or it's like to think about many of the traditional IT the solution is day by day processing, daily processing, or weekly processing, or sometimes yearly processing are doable. But nowadays it doesn't make sense. So it's every time, every moment, it's real-time processing are required, many of them. So it's, which means the velocity is the faster, and which means the big data solution should support such the speed of the data. Then these three being the volume and the variety and the velocity are the three main characteristic of the data. And somebody add one more. It's a veracity. Veracity means the data in doubt. That's I think the very important characteristic of the data. Think about go back to the Matrix movie. So Matrix movie, the most difficult part of to code to make the matrix system is uncertainty. Okay, it's a kind of random decision. But the architect believes it's not really random. There might be probability. It's the same thing in the big data. So if you think about the relational database model, how do you search the data? Using primary key. Select the name, ID, and address from student. Use where ID is 111. It's done. It's everything is deterministic. Because of that, the characteristic, we can easily and faster search query the data. We can just follow the data structure. However, in the big data, if you see my definition, sometimes there are a lot of data. It's very hard to see the meaning of such a data. Whether we don't know this is student data, whether this is the decision data, we don't know. It's a doubt. But if we can process such a big data, then we will get something meaningful information. So it's a doubt, the data is uncertainty. Nowadays, even we cannot only decide this is really student data. It may be possible it's 80% is student data. What 20% is not? It's always a probability that the strategy will be used for the AI and the machine learning eventually. Like sometimes we can classify for example, one of the typical example of the deep learning nowadays is we have the image set, like the cat and dog. Can we classify the cat and dog? So the traditional approach is the cat is like this, and the dog is like this. We have the rule, then select. So that is the traditional approach. But nowadays, if we have such a set of the dog, so we can get the characteristic of the automatically the classify it's called the training. During the training, we can get the characteristic of each of the data set. Then finally, we can use such a characteristic. But it's not perfect. It's at 99%. There is a cat, 1% is dog, something like that. So nowadays, another important characteristic of the data, the big data, is uncertainty data. Who's generating such a big data? As I already introduced a lot. So social media data, scientific data, and mobile device is also the person. I'm interested in such a mobile device as a big data. Definitely, not many systems use the mobile device, the data in the mobile device due to the privacy issue. But if we can process the data in the mobile device, there are a lot of things we can do. Sensor data and more. Then how to use such a big data? This is a traditional approach. Like the business intelligence, BI system. BI system, if I give the example of the BI system is like the Starbucks. So I'd like to open the new Starbucks branch. In the traditional BI system, the BI group, the analyst or something group of person and get together. We'd like to marketing the new branch of the Starbucks. Then this Starbucks usually around the 20 to 30 the age group, and the female and the working the female. So they already know the group of the person answer. Okay, they'd like to know who are they. So select. So ask the IT engineer, why don't you get the list of the person, list of the name and address. The age group is 20 to 30, and the female who are working for the company. Then they make the sequence, select the name, address, and everything from the person or the customer where this group. This is a BI solution. Okay, BI solution usually based on the knowledge of the analytic group. They already know the answer, but they'd like to get such a data that fit to the answer. So that is a BI, the business intelligence. Still a lot, yes.
Professor, like how we can process the data? Like we write some rules in big data.
For the BI system?
No, I'm asking in general way.
Like general way.
RDBMS, we are using table. We are storing data in that.
That's a good question. So, for example, in the traditional legacy system, we use for example the relational database or something other database management system. They are the structured, okay, and sometimes they can use just a file system. Okay, so can those data structure keep the exabyte size the data? No. So to address that one, I do not explain if I give the solution very briefly nowadays, first we need to distribute. Because the centralized server cannot keep all the data, the solution should be distributed. The distribution is one of the thing. Then problem, after we distribute the data, how to process? So parallel processing. So the two parts, the distribute and the parallel processing is the main solution of the big data. Okay, at that time we do not use the table. Some of the databases, solution can support the dispute and the parallel processing. But the traditional, the database management system, like the relational database, cannot do that. So that is another part of the big data solution, NoSQL database. Okay, we will discuss more later.
No, Professor, I did not understand. You are saying that you distribute the data.
Yes. That's the main idea of how to handle the big data.
Like same as RDBMS, the relational data.
That's a good question. Also, I will compare with the RDBMS, the distributed, the RDBMS. But as I said, the relational database, based on what? Relation. If we distribute the relation like the name and ID, there are two ways. We can distribute by the column or distribute by the rows. Okay? If we distribute the customer in the LA in the A side and the customer in the New York, the B side, when we join, it will be huge traffic. So we cannot support we cannot get the full benefit of the parallel due to the nature of that relational model. So we will talk about how to. So we cannot use basically the relay. So even, for example, Oracle support the big data solution like the Hadoop that we are going to use. But that doesn't make sense, actually. It's totally different concept. So it's kind of the totally opposite side. So we will see such a comparison. That's a good question. To understand the big data solution and the big data concept, you can imagine how we use the relational database model. Okay? So I thought the distributed database system, the falsely distribute the relational model, there is theoretically the possible way, but practically it didn't work. So that is the reason I taught 1 or 2 semesters, then gave up. Then this is a more practical solution. But before we enter such a details of it, so this is the traditional approach. So because that the problem is not the data itself is not very complex, so people can imagine the solution of that business problem. Then ask the IT, then get the data. So that is the business intelligence, the BI system. Still, most of the BI system uses such a way. It's kind of based on the relational database and the SQL and just the nice interface, so they can click, and get the data that they want. But if data is more complex and complex, it's the business intelligence using the traditional approach of the BI solution. We cannot get all the data using the SQL and such a static way. So it's more like the predictive, the analysis, like the guess whether. So for example, in case of the new branch of the Starbucks, so at the time we instead of define who likes this one, okay? Instead, we collect all the relevant information or data around this area, okay? How many? What is the main part, like which area is the people stay the more and how long, where they stay, and then if we can get the profile information that we collect such all the data and decide predict which the group of person or which age group of person has the high probability to visit the new branch, something like that. So we will see the similar example later. So because the data is in the big data, it's more complex, which means it's unstructured data. So it's a more predictive model we need, not static model. However, still, many of the companies, they do not give up the business intelligence. They believe it's more to use the big data. It's more complex and it's a huge computation still need, and they believe it's more expensive. Actually, it's not more expensive, the big data solution, but still a lot of companies, small, medium-sized companies, still use the business BI solution. So, big data solution is this is not the main business, but eventually once we have the solution to manage and store the data, big data, then how to use. So we are doing the project, the how to use, first to collect the big data and store the big data and process, but we do not analyze a lot, but eventually the ultimate goal of to use the big data is the how to use, okay, especially in the business. This is still the controversial in the market, whether we really need a big data solution. But from the computer science point of view, we need it because the current computing power cannot handle such a big data. So we need a solution. Then after we provide such a solution, how to use? That's another big question in the company. This is just a simple example how to use the big data. But I noticed it's not important. Okay, so this is a good example. So like a spelling check in the Google. So like the traditional way to check the spelling, we can just look up the dictionary and compare whether it's correct or not. If not correct, we can find the most similar one. Or we can do the natural language analysis. Okay, like the subject followed by the verb and followed by the object, whether that is correct or not. So we can use the natural language processing. However, if we just use the big data, like the how many times the number of the BANAS, but the similar one, the how many times of the bananas. So it's huge, but it's there. So there might be possibility. This one is a mistake of this one. Without knowledge, without considering any other thing or the dictionary, just the use of such a number of the frequency of this one, number of frequency of this one, so this might be mistake. Okay? Then the replace. So that is the one of the way to use such a big data to correct the spelling, the misspelling part. So also government, and this is another example of using the big data in the crime. So not recently, many of the like the LAPD or Chicago PD, the police department did release the crime data. So actually crime data are public, so you can find the crime, the history, or even the location of the how many times the burglar and how many times of the. So you can from the local police department website, you can always search such a thing. However, for example, the LAPD provide all the crime last 80 years the crime data. Then they ask whether there's a solution to predict the crime or not. So if you are interested or if you have an idea, you can use such a big data, then apply the processing tool or algorithm or analysis, and you can, if you can get the better results, you can do your business like that. Okay. Some of the students in my previous semester, they use the police department such as the big data for the big data project. So you can think about this one as one of the example. So you can go to the website and check how to use that. Okay, so then what is the challenges to use the big data? First, we need to store the data. So there are several solutions to keep the big data. So MongoDB is for the database solution, okay? Especially for the document database. It makes sense. If you think about the data, any kind of data, before we have the computer, how can we store the data? We write on the paper. So everything is a document. Also think about the internet web page. What is the internet web page? It's a document, HTML file. It's specifically it uses a hypertext markup language, the structure. It's a document. However, once we are using the relational database management system, relational database model, we try to keep changing the data structure from such a document to the relational model, which means the table style. But then once it is changed, it doesn't look like the document. However, originally, many of the data are actually documented. So if we keep such a document as a data type, then that is the database solution, MongoDB. So MongoDB is one of the popular. So I have seen a lot of students who graduate our program who got the job related to the MongoDB. And we can use the cloud computing also. So GCP is not here. The Amazon Web Services is a top company. You can use the cloud computing, the environment, the cloud computing to keep such a big data. And many other, but in the class we try to use the Hadoop, the big data solution. Hadoop is basically the file system. As I introduced very briefly, it's a distributed file system. We cannot keep in the one local file system such a big data. Instead, distribute. That is one solution. So that is the Hadoop. So we will discuss more about such a Hadoop later. We had the traditional approach to keep such a big data. It's also distributed system. But there are different types of the distributed system. For example, the shared nothing. Shared nothing means we store the data, server, then they are connected, then each of them has their own storage, and the process to keep the A1, A2, A3, and then process parallel. Okay, so this is one solution, but the problem is the processing part is more complex, and they are independent. So it is hard to balance and so on. So there are huge overhead to use such a MPI solution, multiple processor the solution. So it's a traditional way, a massive. Let me skip some duplicate part. Okay, so the requirement, so to build a new solution, actually nowadays it's not a new solution, the big data solution. First thing we need to consider is a partial failure support, which means in this case if one of them is failed, we lose this data. So it's not the complete output. So the new solution, even though one of them is failed, that should be the takeover to the other or any solution. So that the partial failure should be addressed in the big data solution. That makes sense. That is important in the parallel distributed system. We will see how to do that in the head of the solution. So eventually the data should be recoverable, which means that even though we lose one of the data, or even not only the system failure, sometimes the processing. During the processing, the process can be failed. Then this one should be recovered anyway. So not only the data recoverable, but also the processing part should be recoverable. So we will see how we can such a recoverable solution in our big data solution. That is also called the component recovery part of that. Okay? And also the support the data consistency, which means so if the big data solution mostly the select operation or the fetch operation, but not only this one, sometimes it can be the updated and changed. In case of the updating or changing the one of them, how to keep the consistency. So that is another aspect of them. The most important part is scalability. So data is increased. If I add one more node and I increase the linearly increase the performance. So the more the node we have, the better performance. So that should be the big data solution should be the scalable. Okay. So these are the cloud computing and the solution that we know. So our big data solution that throughout the semester we are going to talk about the Hadoop. Okay, so this is the big data solution. Name of the Hadoop is from the name of the poet. It's elephant. It's Tom White, so who developed the first time the 2000 the Google actually encountered the same problem. They had more and more web pages. Do you know how the search engine is working?
Yeah, it works on indexing. Like if we type something hello, then it search H, number of pages of H, then A, it search number of pages of A.
So it's actually basically very simple. So start from the my web page. It's called the seed page. From the seed page, one of the characteristics of the web page is a hyperlink. Each page has the link. So you can easily find such a link from the markup language. Then visit, I have the two links. One is the UB, another one is my friend Harley. Okay? Then visit the copy first the seed page we have. Then visit this one and copy. Then each page has the hyperlink. Then until we see there's no web page, we keep visiting using the hyperlink. As long as your page is linked by another, we can eventually find that. It's called the crawling. So it's copy and crawling. That's it. So that is how the JDM developed the Yahoo first time in 1991. It's a very simple approach and keep copy. Then once we have the new copy, so it's complicated. So there are two servers basically. One is a standby, another one is active server. So one day use this one, the standby server, and collect crawl all the pages. Then at night switch, and this one is the active server, and this one is a standby. Then the crawling again. Okay. Then Google realized that later it's a huge amount of pages. They need to they can do the index and they can do whatever they want, but the problem is the size of the data. So until that time, they used the traditional file system to keep the number of the file, number of web pages, but it's not good enough to. So they developed the Google file system that is